absolutely no interest in getting a Cheeto in the shape of a squirrel on a branch for any amount of money. I'll look at it, but I'm not interested in it. But you know what, Mike? We're being rude to our guests. Here we are chatting away, and we're recording. So hello, everyone. Welcome to Mikroscope. I am Samantha.
I'm Mike.
And
we're talking about rare Cheetos that you could spend lots of money on.
I promise you that behind all of this, we are two very smart people. In fact, Mike is working on his PhD in microbiology, and I do not have a PhD, but I do grow up in New England, and I've always been involved in protecting wetlands and woodlands and all that good stuff. So this show, it's sort of funny how it came about. Mike and I have been friends for, like, what, Mike, 5 years? I hate to date
5, 6.
us.
Yeah. Right?
Oh.
We're still so young.
I know, we're so young. But we've been friends for a while, and I saw Mike over the holidays, and we had a couple drinks. We were here in my living room painting our fingernails, and I asked him how his studies were going because Mike just moved out west to start working on his PhD. And, you know, it was funny how it all happened. I already had a podcast called Dicks and Politics, and I loved hearing Mike talk so passionately about his studies. So I said, do you mind if I record this? He said, not at all. So we were going to release it as just a little sort of extra flavor to Dicks and Politics, but it took off like a rocket and people wanted more. So I said, Mike, can I interest you? May I interest you in doing this on a regular basis? And what did you say at first? Be honest.
So, right, at first I was like, oh, well, I don't know. I don't have time to do that. But then you came out of the woodworks and you were just like, oh, I have like a PR person for you. I have an advertiser. I have like some person who makes art or something. I don't even know.
Creative director.
Oh, is that what they're called? Yeah.
Analytics guy. Yeah, I hooked Mike up. So it's been crazy. I launched Dicks and Politics. We had these 2 little special edition episodes. We had When I Knew, and then we had Mikroscope, which, by the way, if you missed episode 1 of Mikroscope, go back and listen to it because we literally came up with the name on the spot, couple drinks deep, and now here we are, and it's being produced as its own show. Yeah. But we're ready. But, and honestly, now that we're actually sitting here recording this, Mike is really excited about this. So, Mike, tell everyone exactly what you're working on, what you're getting your PhD in, and why it's important to you.
Well, I think I'll start with why is it important to me. And I think that it's just focused around, so I also grew up in the Northeast, in like the middle of the woods. So I have like a very big appreciation for sort of nature and environments. And I think now that I get to study sort of how microbial communities, so this like untapped, this, area of biology that we don't understand a lot about, and how that affects climate change in particular. And the cool thing about the area in which I study this climate change and microbial community interaction is down in the Amazon jungle, which is something that not a lot of people get to go to. And the fact that I do and I get to study it is, I'm so excited. You can't even imagine.
I am so excited because I think that now is the best and most opportune time for us to be doing a podcast about what's really happening. I noticed 2016, 17, and 18, there were so many different mainstream media outlets that were picking up these small little snippet stories about what was happening in the ocean and what's happening in the wetlands and what's happening in our planet, on our planet, on our planet. In our planet?
Around? Oh, around? I don't know. I never put it that way.
Around?
Maybe happening to our planet.
To the planet. Okay, fine. I like that. I like that. So it's, climate change and the discussion of it has crept through the science community. It's into politics. It's everywhere. So people really are trying to understand precisely what is going on, wrap their heads around it, and then see how we can make sure that we can live in a way that will have a positive impact rather than a negative one. But what I did notice
that is something I'd like to do as a scientist, is communicate that to the public.
Exactly. The whole premise behind Mikroscope is basically, so WISP, which is the production company that this is under, like the slogan for WISP is start talking. Like, it's whatever you say, productions, start talking. That's the whole thing. We want to be conversation starters, but we really feel that the best way for us to do that is to give our listeners little bits of information that are just digestible and easy to sort of chew on and remember and regurgitate, so that you guys will formulate your own opinions, maybe do your own research and start your own conversations. So what I noticed was there was a lot of talk, especially in 2018, about what was happening in the ocean. What is really going on? How is plastic and pollution affecting everything? What's happening with the coral reefs? Which then brings me to, in this episode, in our series premiere of Microscope, we're going to be talking about the coral reefs. So, Mike, I'd love for you to start this off. Tell us why. I want you to give me like 3 really specific examples as to why coral reefs are so important.
To start off, let's just, I had sushi tonight. So let's talk about sushi. How are the coral reefs going to affect my ability to get, sushi and salmon and different things like that? Well, if you've ever seen, Finding Nemo or Finding Dory, 2 awesome movies, these coral reefs do act as an ecosystem for baby fish.
Mm-hmm.
And so without these coral reefs, we no longer have sort of these sanctuaries or these daycares for baby fish, which decreases the amount that actually go into open seas and are caught up by fisheries.
Uh-huh.
That is one example of just how important coral reefs are. Another one is we keep having all these storms, right? And all these hurricanes, and we see on the Weather Channel these massive clouds circling around, and we see what's happening above the ocean. But underneath, there's just as much turbulence and just as much chaos occurring within the water. And coral reefs act as sort of a barrier, preventing these waters from essentially washing away our coastlines.
Okay, so they do sort of act, and this like tacks onto the whole thing talking about like the young fish, but they do act as sort of the bottom of the food web, not only for what's happening in the ocean, but also kind of for us. They're also a habitat for marine animals, and I think it's like, what is it? Isn't like a third of all species
within just like 0.2% of the ocean.
Yeah,
it's exactly. Like a crazy statistic like that. I mean, in such a small proportion of the ocean, there's a lot of biodiversity and there's a lot going on, which Absolutely. Makes them so exciting, and reasons we want really to try and keep them around.
Yeah, well,
or do our best to help keep them around.
Exactly, or really understand like what is happening and so on and so forth. I was just reading an article today that there was a scientist that was able to plant like 100,000 little baby corals down in, I think, was it the Barrier Reef or something like that? So, but here's the thing though. Okay, so for those of you who don't know me personally, I used to teach preschool. I now work for a software company where I'm their director of new business. But before all this, I used to teach preschool. And if I said to my kids, all right, what is coral? Do you guys know what that is? They'd be like, oh, it's funny shaped rocks, which, I mean, it's cute. But Mike, I don't really think a lot of people know exactly what coral is. What is it?
Coral, it's the best way I can to describe coral is that it's this intimate symbiotic relationship that occurs between algae, which are the green things that you see on pond scum, but they're also found in the ocean. And then so you know what anemones are and things you see in saltwater aquariums, those mushy type animals actually coat themselves in this calcium carbonate in sort of like an outer shell. So it's a tight relationship between green algae, or maybe I don't want to say green algae, but algae, the species of algae, and coral, and they act sort of to help each other. So corals are animals, so they breathe in oxygen and they release out carbon dioxide. Well, these algae then breathe in this carbon dioxide and then release sugars, which are then used by the coral. And I think I have a crazy statistic where like 90% of the energy generated, or 90% of the energy used by corals come from this symbiotic relationship with algae. So, I mean, it's a lot. These things are super important, which actually then like we might as well transition into sort of like, you understand how important this symbiotic relationship is, but climate change is actually severing that tie.
Right,
So
because it's increasing, like it dissolves the CO2 acidification, so it makes it so they can't, like the algae is like, well, if I don't have anything to eat, and the coral's like, well, I don't have any algae, they're like, bye.
right, yeah, right.
So, see, this
Adios.
is the difference between like you have a PhD, I have a degree in tap dancing and preschool teaching. So there we go. But okay, like in a more technical term, but still,
Okay,
like
yeah.
let's not take it too high level. Explain to me exactly like what this means. So climate change, obviously, let's just say it. Like Mike, climate change is a real thing. The temperature of our Earth is increasing. And not only is it increasing, but it's increasing at rates and speeds in increments that we've never seen before, ever. So, with this rapid rise in heat, what is happening with the coral? How does that affect it? Because some people are like, oh, well, like it's just the air. You know, so I heard someone say this once. They're like, it's just the air. It doesn't affect the ocean. And I'm like, really?
Oh God. Oh
You
God.
know. So talk to me about like, okay, so there's a symbiotic relationship and everything is getting hotter and that's just basically it's like messing everything up. So talk to us a little bit about like what is this disruption? What is causing it and how is it rearranging and shifting things around to the point where everything's like, I'm leaving. I'm leaving
Okay.
town.
All right. Where to begin? Where to begin? All right. So let me wrap in everything Sam just said. Let me just wrap it all back in together. So we understand that we've seen an increase in temperature, which is causing the temperature of the oceans to increase. And we also see an increase in carbon dioxide, which is also increasing so it's making the ocean more acidic. So when the ocean becomes more acidic and or it becomes hotter, the algae actually decides, hey, this environment is like not too conducive to my lifestyle, so I'm gonna shimmy on out of here.
Is that
So
why
when
you left New York City and went out west? You were like, I'm going to shimmy on out. This is just no
no, I
longer for
loved
me.
New York. I love New York. New York is perfect. But I couldn't get paid with the greed I had, so I had to
There
do
you
things.
go. So
Yeah.
it's so
Wasn't the reason,
basically
wasn't the reason.
so
Yeah.
it's dissolving it like dissolves the like CO2 acidification and then the algae is like listen I'm out of here which breaks that symbiotic bond because you can't have one without the other but the algae is the one that's like listen bye. And
Yeah.
then that's why all the coral reefs are turning white, which I think is called bleaching, right?
Yeah, so the actual leaving of the algae from the coral is what causes them to bleach.
Oh my God.
So when coral bleaches, it's not actually dead yet. They're still alive. But think about it. When you rip out a source of energy, right? When you eliminate 90% of someone's ability to make energy, can they really survive for that too long? Or can they survive for that long? No, probably not. And that's the same case that happens with coral. Their sources of food or their chefs, if you were to say, when their
Mhm.
chefs leave, they can't make food for themselves, so they end up dying in the long run. And then that
They're
in
like men when
the
left alone. Sorry.
well,
I
I
said
can
it. I
cook.
said it. I
I can
went there.
cook.
So, okay, we've seen these huge shifts in coral population. So the algae is like, all right, goodbye, I'm leaving. So as a result, we've seen a real change in the populations of coral going to higher latitudes. And that one example that I love is the one in Japan, um, where what? How many miles was it?
I think so. They saw a shift in so right. Coral are contained to a certain temperature, a certain latitude with on the planet due to temperatures. But because temperatures increase and they're shifting so much farther up. So um, I think I wrote down that it's almost 8.5 mile increase um, from where these coral were originally found to where they ended up.
Mm.
So because you see such this drastic change in where this entire ecosystem shifts, bad thing is, right, it has to shift because where it was is no longer habitable. But the interesting thing, and especially me as a biologist, is just like, oh wow, this is awesome, is that it's actually a totally new ecosystem. So new
Hmm.
fish are living within there. There's new microbial communities that are within there. It's playing a different role in a different ecosystem, which is awesome. That's like a novel thing we've never seen, and it's something
Okay,
awesome.
but will they move fast enough from climate change?
Good question. And that is something I think you know, we all want to know. I think there's this overarching question of like, we see how coral is changing and how it's trying to adapt,
Hmm.
but the big question is, can it change fast enough?
Right.
It's
Can
almost it's
it be, in almost like in resistance of climate change, I guess? Because like I said before, we're watching, there was a video that I came across earlier in 2018 where there was a farmer that was farming all of this coral, from little teeny tiny and then getting ready to put them into the ocean. I mean, as a scientist, what do you think if we are making, as humans, if we're making these efforts to grow coral and try to regrow that population, and then thoughtfully put it in places where we surmise it can be successful and thrive eventually on its own? I mean, do you think that that is going to make a difference, or do you think that it's sort of an initiative in vain, if you will?
that is a good question.
Is it yet to
And
be seen?
I will say this. Our there is evidence that has shown that when we provide, where we protect and we sort of try and take care of these coral reefs, that they recover more quickly from these bleaching events. So I think
Okay.
the one thing I didn't talk about is like, even if a coral is bleached, that doesn't mean it can't recover.
Oh, okay.
So
So you did
so
say that
not
it's still
every
alive, but
it is still alive, right? So I think the catch-22 is that not every bleached coral reef is going to die.
okay.
So there's a
Got it.
fine line of like, will it come back or will it not come back? And there's been studies that showed that close to 30, when we protect and we do our efforts, which I think we should actually talk a little bit about, ways to protect coral and
Yeah.
ways we'll talk about. Maybe we'll talk about that in a little bit. But yeah, when we do our part to protect the coral reefs, we do see an increase that can recover from these bleaching events.
Interesting.
And bleaching events are caused by climate change.
Yeah.
Are we piecing together the pieces for everybody? I feel like
No,
we're
okay.
trying. We're
It's a
trying.
lot of information, but I think, again, the biggest challenge with understanding what's happening within the scientific community on a global level, I really am glad that everyone from CNN, NBC, BBC, National Geographic, Discovery Channel, and everyone in between, and even these independent, broadcast media platforms, everyone is really doing their best, and they're putting a lot of thought and time into how they want to produce these quick little videos that you and I come across on Facebook and Instagram. But the challenge with that again is, okay, so then you have to add in this, right? Buy this bracelet. I think I said this before. Buy this bracelet and we will
I think
remove
you talked
three
about this.
pounds of plastic from the ocean,
And
or
save the whales.
and save the whales, and then do
Save
this and do
those
that. And
fucking
then
whales.
there's that girl, that YouTuber. I think her name is like Lauren, and she's like trashes for tossers, I think is what it's called. And she's
I
talking about
know
how
what
she
you're
can fit
talking
all
about.
of her garbage into one little teeny tiny mason jar. So this is something that is top of mind for a lot of people. But I think the challenge is that not everyone knows, like, what exactly is going on, what does that mean, and then how does it affect me, and then what can I do to make sure I'm not having a negative impact on all of this. So all right, so we've talked about what coral is and why it's important. It's protecting coastlines, it's housing small fish, it's the bottom of the food chain web. And then we talked about, okay, so what's happening? Because like it or not, the temperature of the planet is increasing, and the algae that's
CO2
part of
levels are
this,
rising.
yeah,
Yep.
CO2 levels are rising, everything's getting hot. And so now this symbiotic relationship between these, calcium structures and the algae, it's just breaking down because the algae's like, look, this has been great. It's not me. it's you. I mean, what did I just say? And they're leaving.
Clean
So
up the
then,
place. Clean up the place.
clean up the place, crank it up. And then, we have this result, in Japan where it's adding 8.5 miles of an ecosystem and it's creating these novel ecosystems. And then it's like, okay, fine, fine. So this is happening and we can't stop it. And we can't slow it down. So what do we need to do? We need to adjust. So we have these coral farmers who are making coral and they're trying to put it back into the ocean. But there's research behind it, but we haven't seen it. We've never done this before. Not at scale anyway. So we're trying all these different things. We're trying to get involved. But it's like, what is going to work and what isn't going to work? So, Mike, it's funny. I know that you don't like when I say, oh, the balance. And I said this earlier,
Fingers
the balance
in the
is
ears,
always
fingers in the ears.
But I know that the balance is always changing. But, if you had to predict, as someone who's monitoring this very, very closely at a microbial level, if you had to predict what's going to happen to the coral reefs within the next 20 years, where does that put us?
So I can't really say. I can't actually say.
Mm-hmm.
I think it depends on a lot of different. It requires a lot of things to happen. We could stay with what we're doing now and sort of see it all fall to shit. And then, there goes the basis of our fisheries, and then there goes all our seafood. Although there's a lot of other things that play into that, right? We could also see our coastlines,
completely
wither away. Although with water levels rising, like you're just pushing the water up there anyway. I think there's a lot of things that go into this, and it's I'm gonna say it's impossible to give a single answer of what I think. But what I do know and what I do feel comfortable saying is that there are things that can be done and have been shown to actually help save. I don't want to say save, but can help
preserve
or mitigate the effects of climate change on our planet's coral population.
Okay, and so in plain English, what are they?
Okay, so I think there's two of them I want to talk about. And the first is actually sort of to protect the coral reefs from local stressors. So the ocean acidifying and the temperature increasing are both global causes.
Mm-hmm.
But when I talk about a local stressor, I'm referring to, here are just a couple. So farming is one. So, because of the population increasing, farmers have needed to add nutrients to the soil so that the plants can grow more and produce a larger crop. But when it rains, all of that extra nutrients flows into the water and can totally change the balance of that ecosystem.
Wait a minute. Did you hear about yes, but did you hear that all the sunscreen manufacturers now have to change all of their ingredients because we're putting this junk on our skin and then going into the oceans and it's affecting the ecosystem in the ocean? Did you hear about that?
I don't think I heard about that, and I actually don't even know what sunscreen's made out of, but it's not surprising.
Junk.
It's not surprising.
Absolute junk. So then, so really managing farming, making sure that there isn't runoff and
yeah. So managing
so then
the
what
runoff,
else?
Managing tourism, right? So you have a lot of, let's go scuba diving or let's go snorkeling, but you're causing turbulence and you're disrupting it. So you're stressing out that entire ecosystem.
Okay.
Yeah. And these are just a few. I mean, there's hundreds of things, but the idea is that when you disrupt these ecosystems, they become stressed.
Sure.
And so just because they're stressed doesn't mean you're going to kill them. But if they're already stressed and then you put the weight of acidification and hotter temperatures on them, that increases their chances of not bouncing back.
Sure. So let me ask you this. Obviously, you and I, Mike, we might have a little bit of influence at the gay bar down on 53rd and Ninth Avenue, but we don't necessarily have influence yet over the entire world. So we're not going to be able to stop people from going scuba diving or snorkeling or this, that, and the other. Something that we tell young kids is like, okay, sweetie, like, look, but don't touch. If someone were to go snorkeling, right? But they did not go, literally poking around. Would that make a difference? Would that be helpful? Or is it also just from the added pressure of flippers going around all over the place? Like I guess what I'm trying to understand is how delicate is this? I understand it's already got a lot of stressors on it, but are things like snorkeling and scuba diving really affecting it that much? Or if we simply look but don't touch, is that a way for people to be conscientious and be helpful?
Well, I think it's not that, one one person going around, swimming around is really going to affect everything. But for an entire season, for years on end, you have the same coral reef being bombarded by tourists. That's a
Mhm.
lot of stress on one ecosystem.
Well, I will say that I am a
So,
very gentle snorkeler. I go in and I
oh,
look like
I'm
a
so bad.
manatee.
I'm so bad. I'm
Really?
just like
I
I'm just like swimming around like grabbing shit. I'm like, yes, I need this. I need this. I'm gonna study
well,
this.
that's
I'm a
well,
bad person.
but you're a scientist. I am not a
Yeah, you're right.
scientist. I
You're
am a sales executive in New York City. But when I go in, I'm like a manatee. I just bob there and I don't move and I pull my little arms in and I just
right.
clasp them across my
Float
chest
around.
and I float. Yep. And then the second I start to get close to something, I don't even move my like flippers. I shake my butt like a snake. I don't know what's I like I can't be left unchaperoned. I really am not qualified. But anyways, so are there other little things that people can do? Because I know a lot of people tuning in and a lot of people that emailed us and slid into our DMs were like, hey, we love this because it told us like what we can do to help. And yeah, I might be one person, but if there's nothing that the common man can do, can you at least talk a little bit about like what is science doing? Are they doing anything to find a new way to feed nutrition to these coral reefs? Talk to me about that.
I think there is something that Joe Schmo at home can do, but it's not as tangible as I think people would like.
Okay.
So in a recent study, actually maybe not super recent, I think it was in 2016, but they actually, totally experimental. They bleached a bunch of coral, right? And like I said earlier, bleaching doesn't actually mean it's dead. So they bleached it, they stressed it out, and then they added genetically modified algae that were both adapted to higher temperature waters as well as more acidic waters. And they
Okay.
found that these bleached coral reefs actually recovered faster.
Oh,
So, yeah, so we've shown that, we can actually genetically modify an organism to survive within the environment that climate change is going to cause,
okay.
right?
Wait, is this scalable?
I don't know.
Damn it. You know
Is
what?
it
If
well?
if anyone is listening that knows the answer to that, Mike and I were talking and we were like, damn, we should get special guests on this show because we do. I have special guests on When I Knew and Dixon Politics. I would love to have special guests on Microscope. And
Yeah,
we welcome anyone. We open the floor to you. We've
I
got
think
documents you can sign. We're good to go. We're ready. But
yeah.
anyways, Mike,
Like
please continue.
yeah, I mean, I'm just trying my best to tease apart like scientific literature and give it to the public. Okay, right. So is it scalable? I don't know. I think that there goes a lot into it of, this was done in a fish tank. When you're out in the open ocean, this algae could be, you know, could end up getting washed away, or there may be something else that could play a role in sort of it wanting to leave,
Yeah.
even though we've done everything we can to make, to stay with the coral, to make it the coral in the climate change waters as habitable as possible.
Got it. So
But
Here's
so
what we
linking that back, yeah, wait, I want to link that back to what Joe Schmo can do at home. Does it
Okay,
have to be
yes.
Joe Schmo? Can it be like Sherry Shome? I don't
Sure.
know. Is that weird? Okay, yeah, I don't know.
Whomever.
Gender neutral normal person out there. So, right, I think we need to sort of get past the fear of genetically modified organisms. We need to embrace them as sort of this newfound gold that human beings have for tools at our disposal.
Hmm.
So I think what, you know, the person at home could do is help change the conversation about genetically modified organisms and shift it to, if not positive, because I know that's really difficult because I know a lot of people are afraid of it. I
Hmm.
don't think anybody has anybody too afraid of it. Research has shown you really don't have anything to be afraid of it, but you still in your mind are afraid of it. Just shift the people around you to a more neutral and,
Okay.
a neutral context of it.
Sure. So, with all the information that's swirling around today, I think that it is really easy because everything goes around so quickly at scale and on an international level. It's very easy for people to get their wires crossed and get their facts sort of mixed up. So, Mike, aside from doing your own research, what other publications do you like to turn to for little snippets of information to figure out what else is going on within the scientific community?
That is a great question, Sam. That is a good question. And I think one resource I tell my friends at, so yeah, I'm a part of academia, so I have access to a lot of different resources, and a lot of those actually have paywalls. But I think for people at home who want to go and research, very scientifically focused um, articles, Plus One is a really good resource for that. Plus
Cool.
One isn't paying me to say that. I only say that because I really like it. Hey, Plus One, if you want to throw us money, that'd be awesome. But
Yeah, we are not making money doing this really, but okay. So
yeah, no. So I think Plus
essentially,
One is a really good place for people to go and, search up different things. Like I'm actually on the website right now and they have biology and life sciences as one category, computer and information sciences, earth sciences, engineering and technology, physical sciences, science policy. That sounds interesting.
jeez, they've got
Yeah, but
everything.
you can go in here and these are scientists writing these articles.
That's
So
awesome.
they've done their research. We hope.
Yeah.
All been through
That Okay. So basically what we've learned is coral reefs are a vital part of our planet, of our ecosystem, and unfortunately, they are in danger whether we like it or not. They are absolutely in danger, and it's as a result of increases in CO2 and of course the increase in temperature of our planet. But if there's a way for us to know that this is real and flip the narrative a little bit to be a little bit more open-minded about what science is doing in terms of creating GMO food or really researching this and putting out the information rather than automatically shunning it out and saying, oh, no, 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 that just can't be. uh, it can, and it kind of is. So we are going to wrap up this episode. I want to thank everyone so much for joining us. And here's what you can look forward to on Microscope. So again, this is going to come out every other Monday. Our next episode is going to be on the California fires. And then we're going to talk about why climate change is so widespread. And we're going to talk about Twitter, algal blooms, policy, cereal crops, who is most in danger, evolution, asthma, the divide. And then finally, just before the 4th of July, we are going to wrap it up with bees and coffee. So thank you all so much for tuning in. Thank you for your support. Please, if there is a topic you'd like us to cover or a question that you would like us / really Mike to answer, please feel
I'll look
most
it up.
welcome to. Yeah, he will figure it out. Please, I want you to feel welcome to slide into our DMs, comment down below. You can follow us on Instagram at Microscope Podcast, and you can email us. We would love to hear from all of you. So, first official episode, give us a little grace. We're going to find our rhythm. We're going to find what works for us. But thank you very much for joining. Again, my name is Samantha.
And I'm Mike, and thank you all for joining us.
And you have listened to the series premiere of Microscope.